to 9, at the time, we were in the service engineer in the sense the nature of job itself a roaming job. Okay. So how many of them know LMW? How many of them know Coimbatore? Whoever in Coimbatore, they must know this industry. How many of them knows this industry? LMW. Hello. Is it anyone knows about this company? LMW. Yes or no? Is it visible my screen? கணபதியிலெல்லாம் அதோட பிரான்ச்சஸ் இருக்கும் கரெக்டா பெரியநாயக்கம்பாளையம் is the head office. Many of them don't know this industry. Please see, check the revenue of the 2017 only they have updated. How much it was? How much it was in Indian money? Hello? 2,500 crores. Am I correct? Am I correct? So it is an world second textile machine manufacturing industry. Okay, so we know about Infosys, TCS, like that. We have number of companies. Before that, you need to search for them companies available in your surrounding first of all. Okay, this is the Lakshmi Machine Works Limited. They are textile machine manufacturer. Okay, it started in the year of 1962. They will manufacture textile machines. The beauty of this, it is present. It is in Coimbatore, as your friend told. It is in Perinaikembalayam. Okay. Then this LMW is the second worldwide. It is a second textile machine manufacturing industry. Worldwide second. Okay. Then you may ask who's the first. So first falls in the same slide, that is Reater. Okay, RAETER. This Reater office also available in Coimbatore. So these two people are related to the textile industry. இதோட கண்ட்ரி எங்க இருக்குன்னு யாராவது பார்க்க முடியுதா? இது எங்க இருக்குது? ஹெட் குவார்ட்டர்ஸ் எங்க இருக்கு? anyone tell me where it is? The Reater. Switzerland. Okay, so Switzerland in the industry. Okay, then Lakshmi Machine Works in India. These two people will manufacture the textile machine. Okay, நம்ம பார்த்தோம்னா school daysல எல்லாம் addressல பார்த்தோம்னா you may know one thing is the common landmark. ஏதாவது ஒரு மில்லுன்னு சொல்லி நம்ம அட்ரஸ்ல வந்திருக்கும். நிறைய பேர் அட்ரஸ்ல அது இருக்கும். கரெக்டா? மில். நம்ம அட்ரஸ் லேண்ட்மார்க்ல ஏதாவது ஒரு மில் ரோடு, கோயம்புத்தூர்ல மில் ரோடுலாம் இருக்கு. ஸோ மில்லுனா இது நிறைய மில் இருக்கு, கிரைண்டிங் மில் நிறைய இருக்கு. இதுல வந்து டெக்ஸ்டைல் மில்ஸ் இஸ் வெரி வெரி பாப்புலர் ஒன். தேர் இந்த ஸ்கூல்ல படிச்ச மாதிரி தான் தே வில் கன்வெர்ட் இட் ஃப்ரம் காட்டன் டு யான். ஒரு நூலை ப்ரொடியூஸ் பண்ணுவாங்க. எதுல இருந்து எங்க வருது? பஞ்சுல இருந்து நூல் வரும். You don't think this is not a very simple process. In between we are going to have minimum of 10 machines, minimum 10 process carry out pannada you will get the yarn. So making the yarn is not a very simple process. There also they are using plenty of automation machines and algorithms to get the yarn with the same thickness. யானோட திக்னஸ் எடுத்து பார்த்தா ஒரே மாதிரி இருக்கணும். ஓகே, so it is a very very tedious process. Diploma engineer itself they are doing well work in this area. Okay, in that industry I worked as an electrical service engineer. At that time we used to travel many places. One day there is a complaint, one three-phase motor drawing abnormal current from the supply, and it is getting repeatedly shut down or tripped using some productive mechanism. So if we couldn't have this productive mechanism, the motor will get damaged. So they're given on production element. So repeatedly if the motor gets off, what will be the problem to the company, what will be the production of the company, are they can able to create the production, or they will get an interruption. Mission continuously ஓடல, ஆஃப் ஆயிட்டே இருக்கு, அவங்களுக்கு லாஸா ப்ராஃபிட்டா?
Loss.
லாஸ். am I correct? ஸோ அந்த இண்டஸ்ட்ரி எல்லாம் பார்த்தீங்கன்னா 1 hour ஸ்டாப் பண்ணாலே their losses will be in lakhs. If you are considering the steel plant, the same 1 hour shutdown will create 1 crore loss. So these kind of things will reflect back to the engineer's head. They will fire the engineers, then they will ask the reason why this production loss. Okay, then what they will do, usually the internal engineers will try to troubleshoot, or else they will call the service engineers who manufactured or taking care of the particular machine. They will call. Okay, I visited to that industry. It is near Kolkata, I think. Language is the very big problem to me. I don't know Hindi much, so I can manage with only English and Tamil, Telugu and few languages, not that much fluency in remaining. Okay, then I visited that particular mill. They are giving the complaint that it is getting tripping every time, we are unable to run the machine, and one more pressure on me, it is a very newly erected machine, so the customers spend already lakhs to invent the machine, as to install the machine, but they are unable to get the production. So the solution has to rectify the issue within a short time. Then we tried many magics, everything looks perfect, but there are few deviations we noticed at the time. The one is let me consider the motor hereafter as on a box, and also consider only 2 wires, not a 3 wire. Okay, so usually if the system draws more current from the input supply, what are all things you will check? This is my input AC voltage, it draws more current, therefore only it gets trips frequently. What are the things you will check? First I need to check the input source. Am I correct? What is the voltage we are applying across this system? Am I correct? Shall we consider as a V in? Yes. Then we need to take the V in voltage. Then I need to measure the current through the particular wire by introducing ammeter. Am I correct? Introducing ammeter. So we found the ammeter current at the time of measuring was perfect, and the voltage is also perfect. Then we enquired them, then only they told the one real thing, it is not happening in this time, during half peak hours. Okay, half peak hours means you know the schedule, or 9 o'clock munnadi, then after 6 o'clock half period, upper load kammiya irukum. At that time they are facing one issue, that increase in voltage. So voltage increase ana current enna agum sir? Automatically current will get increase. இந்த ரெண்டையும் டிபெண்ட் பண்ணி ஒரு பாராமீட்டர் இருக்கும் ஓம்ஸ் லால. வாட் இஸ் த தேர்ட் ஒன்? கொஞ்சம் குயிக்கா, வாட் இஸ் த தேர்ட் ஒன்? ஐ இருக்கு, வி இருக்கு, இன்னொரு பாராமீட்டர் இது இருக்கும். வாட் இஸ் தட் ஒன்? தேர்ட் ஒன்? ரெசிஸ்டன்ஸ். How you will measure the resistance? At the time also I had the same brand meter, this Fluke 115. This multimeter cost is around 7,000 rupees. In your market, if you check, the price of the multimeter starts from 200 rupees. So it is a well calibrated, it is a true RMS meter. You consider it is a ohm meter. So then what we have did, internal of this motor, if you find the equivalent inside that, will have 3 coils. That's all. Inside the motor you have a 3 inductor. Okay, so the inductor will possess some resistance. We measured 3 winding resistance, R, Y, B are the 3. So we measured R phase, Y phase and B phase. In all the three phase, it is giving some values. Say example, I not remember, 3 ohm, 3.1 ohm, and 3 ohm. So it seems perfect. 3 windings are balanced. Correct? Mono balanced. Then we checked the nameplate detail and the data sheet of the particular motor. In that, they mentioned as 1.8 ohm. It should be 1.8. If you are a service engineer at the time, what you will conclude? Actually, Lakshana, you need to tell the answer. You only triggered this one. This is the data sheet given by the manufacturer. This is the real reading. What you will conclude from this? Lakshana, are you there? Hello? Sir, am I audible?
Yes, sir. Audible.
Lakshana, what you will conclude? மோட்டோட மேனுஃபேக்சரர் 1.8 am கொடுத்துருக்காங்க. நம்ம மெஷர் பண்ண ரெசிஸ்டன்ஸ் அதிகமா இருக்கு. மோட்டார் டிஃபெக்டிவா இல்ல நான் டிஃபெக்டிவா? Okay, is it deviates or not deviates? அவங்க கொடுத்த ரெசிஸ்டன்ஸ்க்கு நமக்கு அதிகமா இருக்கா இல்ல அதே வேல்யூ இருக்கா? ஹலோ, நீங்க தூங்கியாச்சா? ஹலோ சார், ஹலோ.
Yes, sir.
கண்ணா சொல்லுங்க, ரெசிஸ்டன்ஸ் ஒரே வேல்யூ இருக்கா வேற வேல்யூ இருக்கா? அதிகமா இருக்கு. அப்ப என்ன அர்த்தம்? வாட் யூ வில் கன்க்ளூட்? இது given, இது measured. So simply we wrote the letter to the manufacturer that your winding resistance are deviate from the given standard value, and we packed everything, and I am returned back into the Coimbatore. கோயம்புத்தூருக்கு டிராவல் பண்ணிட்டு இருக்கோம் கொல்கத்தால இருந்து. In between the time, we are getting the call from the particular company, and they asked one thing: have you read the data sheet properly? I told yes. You mentioned only this resistance value, but we got this. Then they asked one question: whenever you measure the resistance, you need to consider the one more parameter. Can anyone tell me what is the parameter? At temperature பார்க்கணும். So this particular motor was manufactured in abroad, Switzerland or Germany, I forgot that one. Their normal temperature itself very less, and also they given in the data sheet that at 20 degrees Celsius. Can anyone tell me, while I measure the resistance, whether the resistance, so temperature at the working place will be 20 degrees Celsius in India? What may be the temperature? What may be the temperature? What may be the atmospheric temperature? 32. It is an industry. I was having plenty of machines. Whether temperature அதிகமா இருக்குமா கம்மியா இருக்குமா?
அதிகமா இருக்கு.
Obviously it will be high. Almost it is near about 38 or 39 or 40 degrees Celsius வரைக்கும் இருக்கலாம். Correct, sir? Is it possible me to traveling back and getting the motor? It was already couriered, and measure the resistance again in this particular temperature? Don't think whatever the simple mistakes we are doing in the industry may take you to not to Coimbatore, from Coimbatore to, it will take you to here. What is this? Can anyone guess what is this?
Manufacturing.
Take you to your home. they will terminate you because the particular motor cost itself more than 30-40,000 to dispatching this motor to where we dispatch this motor to other country. What is the flight courier charge? If it is a defective, they will accept. Okay, they will give the replacement. But we measured the wrong thing and we sent the good product to them. So to and fro flight charge the customer need to give. Is it acceptable, sir? இது என்ன mistake? அதுதான் அப்ப Ohm's law படிக்கும்போது at constant steady state temperature the current flowing through the conductor is directly proportional to the potential difference between the two terminals of the conductor னு படிச்சதுல I forgot at constant temperature. What is, see, this is the very big thing. Whenever you are measuring something or measuring some voltage, any quantity, first and foremost thing, put the heading, what is the temperature at that surrounding you are measuring. Because in Kodaikanal or Ooty, if you take the same experiment, you won't get the VA characteristics as the same all the time. And the temperature மாறும்போது the VA characteristics falls in a different way. The resistance value in a very low temperature, the resistance will also be low. So it will lead many things. This is a very bigger area where you need to focus me, that is your defense. So whenever we are manufacturing something, the number of transistor or the ICs present in your military vehicle need to operate from some minus 100 degrees Celsius to plus or 125 and 225 degrees Celsius operate ஆகிற மாதிரி they will design. So semiconductor devices, always there are two grades. One is the extreme temperature range, another is the normal environment range. So this cost will be very, very high than this, because in defense area, so high hill places also we are placing our vehicles. In the military vehicle இருக்குது, there you will find minus degree temperature. In the same place, irrespective of the time, the temperature may get increased. Can anyone tell me? I am keeping some vehicle over here. At present, my temperature is minus 20 degrees Celsius. With no time, it will get into high. Can anyone tell me the scenario, what it is? The temperature minus. Wait. Hello, please loud.
Early morning to afternoon.
No. Same time in the area temperature I can increase up to 200 degrees Celsius. How? With no time. During the war, the opposite person may trigger some rocket launchers to nearby to your place. At that time, what will be the temperature of your vehicle? It will be very high temperature. So your devices always need to play between minus to plus. So whenever you are writing some coding, at that time you need to consider the temperature range. Accordingly, you need to give some adjustments. So keep it in the mind. So thanks to Lakshana, since he discussed the temperature different place, our temperature, our temperature, ரொம்ப wider changes இருக்கும். So you don't think that in the theory portion, wherever we are studying as a temperature, it is not a simply temperature. It will do many things. Okay. So if you are interested, go and browse defense relevant products. Okay. So I will show whenever you will find free time, I will show that components. Okay. Even you can. Yes. Solution only the motor came back. I got fired from the industry and the particular they asked only one thing: are you an engineer? That's all. That is a simple question they asked. I am very ashamed to that. That is a very blunder mistake of mine. So we recommended the customer to regulate their input voltage. See, always we will give some tolerance to the customer. Nameplate details we will plus or minus 10%. We will give a rating. So I thought that so plus or minus 10% mean from this low voltage to high value. Say example 380 to 450 we can operate. I thought they are sometimes they are getting this voltage and they are keeping the same voltage for long time, 1 hour 2 hour. Then at the day only I come to know that this tolerance is given for very short time duration. Time is the another quantity you need to check. So whenever you find the tolerance, how long you can give this tolerance is the second one we need to capture. I measured the voltage and not I measure. They told sometime we will get 440 volt. Then I checked the nameplate it is 10%. Then I didn't take and it is a very big factor for the problem. I left the industry. Then the head of me fired me like anything. Are you studied these things in your college days? What you learned from this? They asked. I told we can maintain this tolerance. Then only he told that you are a fool. Go and read it once again. This time duration you need to consider. This tolerance level you need to give it for a very short time. I can give you one example. I am the human. I can lift 50 kg, but my range will be from 0 kg to 100 kg. Keep it like this. So is it possible me to carry the 100 kg for 2 minutes? Maybe possible. Is it for 1 hour? Is it possible? Possible? No. So that is the conclusion. So whenever you are reading anything, read it properly. These two T's, capital T and small t, will matter a lot. Capital T is the temperature, small t is the time. Okay. So whenever you read any parameter, keep these two things in your mind. I will show you few data sheets at the end of the session. And all the data sheets, you will find temperature is the one of the parameter. Okay. Shall we get into the class, please?
Sir, one నిమిషం.
Yes, sir.
50, 137, 50. Please respond.
Hello, Prithvi.
சார் இன்னைக்கு வந்து 21வது செஷன் சார்.
ஓகே.
இதுல எல்லா செஷன்ல அவன் ஆஃப்டர் 20 minutes தான் கிளாஸ் ஜாயின் பண்ணிருக்காங்க. இன்னைக்கு 11:41க்கு அவன் ஜாயின் பண்ணிருக்காங்க. சோ இன்னைக்கு நான் ஆக்சன் மார்க் பண்ண போறேன் சார்.
நீங்க இவ்வளவு நாள் அட்டெண்டன்ஸ் கொடுத்தீங்க பிருத்திவி?
இல்ல பிருத்திவிக்கு நான் ஜஸ்ட் அவன் கன்வே பண்ணது. என்னால கன்வே பண்ணல. இன்னைக்கு நான் கன்வே பண்ணது பிருத்திவிக்கு. இன்னைக்கு இல்ல முன்னாடி ஆக்சன் போட்டுக்கிறது இன்னைக்கு ஆக்சன். ஓகே. நீ இப்படி ஜாயின் பண்ணனும் அவசியம் இல்ல பிருத்திவி.
சார் நம்பர் என்ன சார்?
137.
Kana, see, it is a choice-based credit system. If you are absent for a particular subject, you won't get the hall ticket to write the particular subject alone. Do remember this one. Okay. Prithvi, any issue? Kana, Prithvi, ஏதா issue இருக்கா உங்களுக்கு? Prithvi? Hello? So, okay, sir. I will. If I'm first வரனே சார். So every day he will join first.
இல்ல சார். இன்னைக்கு கூட அவன் 11:41க்கு தான் ஜாயின் பண்ணிருக்கான்.
அவன் ஃபர்ஸ்டா உள்ள வந்துட்டு வெளிய போயிடுறான் சார் டெய்லி.
அது ஆள காமிக்கிறதுக்கு நினைக்கிறது.
Every day he is the person join first. Okay, let me check that one, sir. Thank you, sir, Sajid sir. Okay, shall we start the today's class? Where we stopped, can anyone tell me? Okay, some of them may be absent for the last week classes. Okay, so let me quick refresh what we have learned. We are going to learn MOSFET in this under the topic types and its a symbol and its a circuit model. These things are we are going to study. So far we have discussed what is FET, why it is called as an unipolar device, then what is the field effect, then this is a wonderful animation how the field effect transistor works, then advantage of your field effect transistor, and types of your FETs. Okay, so under the family you have JFET, MOSFET and MS MOSFET. Then in each and every type you have a subtypes. Okay, that is like a N channel, P channel. Then once you come to the MOSFET and MS MOSFET, there is one major type is enhancement and depletion. Okay, under that also we have two types, N channel and P channel. Okay, so we discussed what is FET in detail. Then the depletion and enhancement also we discussed in a very little way,
Sir,
not in depth. Yes.
sir, Prithvi sir, கொஞ்சம் network problem அதனால வெளிய போகுது sir.
Prithvi, network problem na, please change the SIM. Okay.
Sir, இல்ல sir,
Exams
இன்னைக்கு மட்டும் தான் sir இப்படி ஆச்சு. மழை பெய்யுது sir, அதனால இப்படி இருக்கு sir.
எந்த ஊர் நீங்க?
Sir, நாமக்கல் sir.
நாமக்கல்ல பாத்துக்கோ பிரித்திவி, சரியா? See, every class you are joining as a first person, but while sir taking the attendance, he will take attendance multiple times. First 20 minutes la நீ absentன்றது complaint. உனக்கு attendance இது வரைக்கும் absent தான் mark பண்ணிருக்கு. அது rectify பண்ணு. If anyone facing this kind of issues, you need to tell us, or else we can't know. I know Prithvi is the person joining every day first. But while I am taking the class, I told you I am the Google Meet blind. Whenever slide is present, பின்னாடி என்ன நடக்குதுன்னு எனக்கு தெரியாது. ஓகேவா? Yes. So those symbols we have discussed. Then we are going to start our discussion with the MOSFET. In that MOSFET also the first discussion falls in the enhancement N channel MOSFET. Okay. So in that we have seen types of MOSFETs. Yes. What is the definition? Why the MOSFET name arrived also we checked with this diagram. Metal, oxide, semiconductor. Correct? So layer form பண்ணும்போது எப்படி form பண்ணுவாங்க? They will start from metal or they will start from semiconductor to metal. What is the flow? What is the flow? Semiconductor to metal is the flow. Yes, very good. And also, why this is SiO2, sir? Why this is SiO2? What is this? Silicon dioxide. It is insulating layer or a conductive layer? Insulating layer. Very good, very good. So then, this is the analogy given in your one of the textbook, Boyle's state. So source, gate, drain. Okay, what? So the image is not much clear, but you can understand. This is source, this is drain, this is gate. So from the analogy only they say, can anyone tell me what is the flow equivalent to our system? Whether it is a IB or IG or ID. Three options. IB.
G, sir.
IG. These two are odd man out. Say IB, it is for transistor. Okay, va? So transistor terminology inge varadu. IG. Can anyone tell me what is the typical IG value we have studied in the last classes? IG. Again options are okay. 0 ampere, 1 ampere, 2 milliampere.
Ideally zero, sir.
Zero. Why it is 0?
No current.
Input impedance is very, very high. Therefore, this also eliminated. But then what will be the answer? ID. MOSFET பொறுத்தளவுக்கு current flow discuss பண்ணோம்னா we need to discuss only the drain current. Okay? Yes. Then what else? The symbol you know. I hope you have the symbol in your hand. Then from this we will start our discussion. Last class also we stopped little ahead. Let me start from here, no issue. Okay. So what is the today's date? What is the today's date? Make date in a sir?
24.
24/5. mark the date and start right. Okay, yes. So first we are taking P substrate. Then in the P substrate, we are making doping and creating N layers. Okay. Then after this diffusion process, what we need to do? Can anyone recollect and tell me? After this process, what we will do?
Silicon dioxide.
Silicon dioxide coating. Yes, silicon dioxide coating. Why, sir? Why I need to do the silicon dioxide coating over there? To create which terminal? To create
Gate, sir.
gate. To create a gate terminal. Okay. So before getting the gate terminal, let me create the source and drain terminal first. So from the N layer, we are making this color indicates the metal. Okay. This color and this color are semiconductors. Okay. So metal color totally different. Please observe. So these metal contacts, and from that we are taking little wire and terminal. So this is my source terminal. This is my drain terminal. So it is a 3-terminal device. We formed 2 terminals. What about the third terminal left? What about the third terminal left? Gate. Where I need to create the gate? Let me give the options 1, 2, 3. Where you will get the gate terminal?
2.
2 is the right answer. 2 is the right answer. Here I need to form the third terminal, gate terminal. That's all. So we created the N type enhancement MOSFET. Is N type or P type? N type. N channel. N channel enhancement MOSFET. Okay. Actually, this regions are called as a channel. இதுதான் channel சொல்றோம். சார் ஆனா இங்க P type இருக்கே சார், N channel சொல்றமே சார். Why? என்ன இருக்குன்றது பிரச்சனை இல்ல, எது ஆக்டிவா நமக்கு யூஸ் ஆக போகுதுன்றதுதான் மேட்டர்ஸ். Am I correct? அப்ப இதுல ஒரு விர்ச்சுவலா ஒரு சேனல் கிரியேட் ஆகும். அது என்ன சேனல் சார்? That is the N channel. That is the induced channel. So this channel only going to help for conduction. Can you please tell me? அப்ப யாரு பெர்ஃபார்ம் பண்றாங்களோ அவங்க பேர் சொல்லி தானே கூப்பிடுவாங்க. அப்ப இது என்னன்னு சொல்லி கூப்பிடுவோம்? N channel or P channel?
N channel.
Who is N channel? Okay. Yes. Don't get confused with the substrate what you have used. Is it clear, dear students? Yes.
Yes, sir.
Now what we are going to do? See, there are few things you need to note down. Metal or polysilicon plate is used where? Over the silicon dioxide layer to form the gate terminal. Okay, va? So in the coating ke enna coating use பண்றாங்க? Metal or polysilicon plate. So in the metal coating எல்லாமே இதை யூஸ் பண்ணி தான் பண்ணிருக்கு. Please note down. Shall we move from here? So now successfully we have fabricated the MOSFET. Yes, sir? Yes. Now we will proceed. Let me discuss one more point over here. Here they include one. Actually, here you need to take 3 takeaway points from this slide. Okay. The region between the drain source in the substrate is called channel. Okay. So இந்த ஒரு போர்ஷனை மட்டும்தான் சேனல் ரீஜனா நம்ம எடுத்துக்கிறோம். ஓகேவா சார்? Okay. Why I am going to take this is only a channel region?
Because the electrons flows to the
Only in this region the electrons going to travel. Am I correct, sir? That is the first takeaway point. The second point, the length of the channel, don't think it will be in the centimeter or meter or kilometer. These are all in micrometer. Can anyone tell me what is the present technology? It is the micrometer technology, nanometer technology. What is the recent IBM nanometer distance?
2
2 nanometer. 2 nanometer. Recent IBM manufactured 2 nanometer. 2 nanometer mean what? 2 into 10 to the power minus 9. Am I correct, sir? Am I correct? So this much smaller distance between these two, source and drain. Please think about the technology, how precise it was. Okay, so whenever the channel gets very closer to this, without giving any voltage, it may get contact with this. Correct? அப்ப அந்த அளவுக்கு இங்க டெக்னாலஜி வந்து கண்ட்ரோல் பண்ணி they manufacture. Actually 2 nanometer வந்து it's a very big challenge. இப்போ மார்க்கெட்ல at present 12, 10 அந்த nanometersல தான் மொபைல் போன்ல இருக்கிறதெல்லாம் அவைலபிள். ஸோ 5 வரைக்கும் இருக்கு. ஓகே, 5 வரைக்கும் உன் கையில இருக்கு. சரியா? 2 nanometer soon you will get. Okay, yes. And one more takeaway point. Let me ask one thing. I am not applying any gate supply. Okay, consider this as a one circuit. இப்படி ஒரு சர்க்யூட் இருக்கு. இந்த சர்க்யூட்ல கேட் கரண்ட் கொடுக்கலன்னா இது சர்க்யூட் ஓப்பனா இருக்குமா இல்ல க்ளோஸா இருக்குமா? Open. So if I am not giving any input to my system, it will be in off state. Therefore, this enhancement MOSFET is also called as normally off. Normally off la da irukum. Correct? If I am giving some gate signal, then only it will start conduct. At that time only my switch will get close. Is it clear, sir? Is it clear? Yes. Shall we move from here?
Yes, sir.
Yes. Next, 3 takeaway points: channel region, length of the region, then normally off. Okay. Yes. Then let me start give the biasing or giving the operating voltage and make the system to conduct. Okay. So this diagram is don't bother about the sentence false over here. Check only this one. How many sources were present in this diagram, sir? How many sources were present over here? How many sources present over here? Yes? Hello? எவ்வளவு source இருக்கு, sir? 2 sources are present. Am I correct, sir? Hello?
Yes, sir.
2 sources are present. Okay. What I am going to do, I am going to change the circuit into a little modified one. Okay. Understand the concept. Okay. Then thereafter you need to compare this system with this one. இதுல உனக்கு கன்ஃபியூஷனே வரக்கூடாது. இல்ல இந்த டயகிராமையே கொஞ்சம் நான் வேற மாதிரி டிரா பண்ணி காட்டி அண்டர்ஸ்டாண்ட் பண்ண வைக்கலாமா? Which one you will prefer? இப்படி டிரா பண்ணணுமா இப்படி டிரா பண்ணலாமா? Which one you prefer? Please tell. We will go with that. Okay, let me try with this diagram. Can I make you to understand? Else we will go with the second time. Okay, sir? இந்த டயக்ராம் இப்படி பார்த்தீங்கன்னா உனக்கு வந்து எல்லாமே ஒரு சர்க்யூட் க்ளோஸ் ஆன மாதிரி ஒரு ஃபீல் வரல. Therefore, what we are going to do, we are going to make you to understand by keeping 2 sources in your hand. Okay, this is one source. This is the another source. Don't confuse about the ground symbol. Let me time being, let me erase this. Okay. Yes. Now VGS means what? VGS. எந்த டெர்மினல்ல பாசிட்டிவ் இருக்கணும், எந்த டெர்மினல் நெகட்டிவ் இருக்கணும்? Can anyone tell me? VGS. VGS. எதுல பாசிட்டிவ் இருக்கணும், எதுல நெகட்டிவ் இருக்கணும்? Any idea? The first letter is the positive. Second one should be the negative. புரியுதா sir? So VGS la G ka I need to connect positive. Then VS. அவ்வளவுதான். I have connected one source. Okay, sir. Then the second source I need to connect across VDS. VDS na enna artham? Now you help me to finish the diagram. VDS. What it means? Enga positive, enga negative.
Drain positive.
Drain positive. Drain positive. Drain positive. Source negative. Let me have this line is also with the black. Okay, how many sources were present now? How many sources are there? Two sources. Okay, two sources. Let me have a discussion with this diagram. In this diagram, now I am going to connect this bulk terminal or the body terminal also to the ground. That's all. Understand ஆயிடுச்சா? இவ்ளோ பெரிய டயகிராம் தான் அங்க ஸ்லைட்ல எப்படி காட்டியிருக்காங்க? ஸ்லைட்ல எப்படி காட்டியிருக்காங்க? ஸ்லைட்ல இந்த கிரவுண்ட் எல்லாம் எலிமினேட் பண்ணிட்டு this given the symbol with this reference. Is it clear, sir? Please take a screenshot of this one, else draw it once. Please draw the diagram once, because hereafter we are going to have a discussion with the thing available in the slide only, not this diagram. Okay, now if I consider I am having one switch over here. I am having one switch over here, and initially I kept open. Okay, what will be the voltage across my VGS?
0.
0. At the time, is there is any channel present in between this?
No, sir.
No. At the time, what will be the current through the circuit? ID
0.
See, ID current path, let me explain you. It has to come from here, then here, then it need to reach here. So this is the current path, but it is an open switch. Am I correct, sir? This is the open switch. So therefore, ID is equal to 0. Take down the first one. This is understand, sir? So now my device is the open switch. Again, case 2, what we need to do, sir? Can anyone tell me what I need to do?
Close the circuit.
Close the circuit. Okay, close the circuit. Then give some voltage. Adjust the voltage. Adjust the voltage to some value. What will happen? What will happen? Please consider we are getting one channel. That's all. We are getting one channel. We will discuss how we are getting the channel in the slide. Okay, now you tell me, once I got the channel, what will be the equivalent of this path? It is a open switch or closed switch? Closed switch. At that time, what will be my drain current? Is it equal to 0 or greater than 0?
Greater than 0.
Greater than 0, provided you applied some VDCs. VDC, if you keep 0 volt, even after you are giving the VGS voltage, this current will be remain 0. Okay, so here consider we are giving some voltage also here. So my circuit is getting conduction over this. Now you tell me, MOSFET can also used as a what? MOSFET is also used as a what?
Switch.
Semiconductor switch. Am I correct, sir? Semiconductor switch. Controlled by VGS. Controlled by VGS. Sir, இதெல்லாம் எப்படி சார் நம்ம கண்ட்ரோல் பண்ண முடியும்? How really they are doing? In your mobile phone also you are having number of MOSFETs. Okay, so the MOSFETs எல்லாம் எப்படி trigger ஆகுது அப்படின்னா, Let me give you only one small example. This is your mobile phone. You are touching one icon. If you touch with your finger, the second window opens. That is the window for the particular application. How this thing happen? You are triggering something that make the transistor present inside the things to close. The closed signal is given to your controller. That controller have a number of lines, number of switch cases. Say example, this is the Swayam app. You have it in your mobile. This is the online platform to learn. After the class, you are clicking this app, Swayam app, and the app open ஆகிறதுக்கு you have a number of lines that fall in any one switch case. இதை நீ click பண்ணும்போது switch case open ஆகுது. அந்த switch case குள்ள you are reading something. How you are reading something? Again, you are making many transistors to on and off to create the character in the display. Display la character ஆகணும் அப்படின்னா it is an LCD display. So அந்த liquid crystal display க்கு அதுல இருக்கிற crystals activate பண்றதுக்கு you have to give a triggering. So likewise, you are going to write a n number of codings to trigger your MOSFETs. I hope now the structure is understandable to you. Okay, shall we go with this diagram hereafter? Shall we go with this diagram hereafter? Yes. The first condition. Hello, sir. Yes. Hello. Hello.
Yes, sir.
Sir.
Okay. Yes. First condition, put a title, operation of n-channel E-MOSFET. Please take a title. And I hope you have the previous paint diagram in your hand. Am I correct? What are the diagram இருக்குல்ல? Yes. I erased that one without taking a screenshot. So if anyone took a screenshot already, you share it to me. Okay. Because in the next class, while revising, I will use the same image. Okay. Yes. Now we come back. The first condition. VGS greater than 0 volt. That means what? I am making the switch to close. Also, I am adjusting the knob to get some voltage across this VGS. So between these two regions, we are going to apply something. That is what? VGS. If I apply some voltage across this, please observe something is moving now. So this is the p-type material. What is the majority carriers in the p-type material?
Holes.
Electron or hole? Yes. Holes is the majority carrier. Who is the minority carrier, sir? Electrons. So the green color la காட்டியிருக்கிறது என்ன sir? What is that?
Minority.
Minority carriers get attracts towards the positive terminal connected in the gate. So unlike poles attracts, unlike charges attracts, so the negative charge moves towards this edge, but it unable to travel further. Why? Who is restricting to not? Yes, this layer, that color is not much visible to you people. Let me highlight the portion. இந்த highlight அதுக்கு மேல என்ன கலர் எடுக்கலாம் டக்குன்னு சொல்லுங்க. ஹைலைட் பண்ணா டக்குன்னு தெரியுற மாதிரி ஒரு கலர் தெரியுதா சார்?
Yellow.
Yes, sir.
This highlight, this insulator won't allow this minority carrier to reach this source. Therefore, it will wait here. இங்க வந்து உட்காரும். பார்க்கலாமா? Shall we see that one? அந்த தியரி இங்க கொடுத்திருக்காங்களா சார்? Whatever we discussed, the theory is okay to you?
Yes, sir.
Okay? Yes. If you took a notes, please say yes. We will go to the next. Very simple. VGS greater than 0, VDS greater than 0. எதுக்கு சார் greater than 0 சும்மாவே சொல்லிட்டு இருக்கணும்? இங்க போடு 1 volt போட்டுக்கோ, இங்க 2 volt எழுதிக்கோ. 1 volt 2 volt ஒரு எக்ஸாம்பிளோட போய்க்கிறோம், நோ இஷ்யூ. இப்போ greater than 0னா மனப்பாடம் பண்ணுவாங்க, greater than 0 greater than 0 greater than 0. 1 volt 2 voltனால மனப்பாடம் தான் பண்ண போறோம்னு சொல்றியா? மனப்பாடம் பண்ணினா நீ ஜாலியா ரிவர்ஸ்ல வந்துட்டு இருப்ப, ஃபோன் கால் வரும், மாட்டிக்குவ. சரியா? எஸ். ஏசி பஸ்ல தான் வருவேன், ஏசி ஃபீலிங்கே இருக்காது, ஸ்வெட்டிங் வரும். ஏன்னு சொல்லு? they will kick you back to always mistake பண்ணா இத நாம வச்சுக்கணும். What is this symbol called? It is not work from home, kicking back to home. Okay va sir? Yes. Then next one. This it won't allow the electron to reach the gate terminal. Why? Because my insulating layer have high impedance, very high impedance. Okay, so due to that it won't allow to reach there. Yes. Now we will move to the next. Applying positive gate voltage and small drain voltage, okay, that will going to make something. What is the thing? Due to this input voltage, successfully induced channel. Induced என்ன சார்? எங்கேயோ படிச்சிருக்கவே, primary winding, secondary winding. We will give something in the primary, we will receive something in the secondary. What is that, sir? This is the principal operation of transformer. படிச்சிருக்கமா? Is there is any electrical connection between these two?
No, sir.
No. Only electromagnetically coupled. அப்ப இது எப்படி சார் கப்பிள்டா இருக்கு? இது எலக்ட்ரோஸ்டாட்டிக்கா கப்பிள்ட். எலக்ட்ரோஸ்டாட்டிக் எங்கேயோ படிச்சிருக்கமே சார்? capacitors 2 plates separated with the insulating medium. அதே மாதிரி இருக்கா? இது ஒரு பிளேட், இது ஒரு பிளேட். கரெக்டா சார்? கரெக்டா? அப்ப இங்க வந்து due to the induced there will be a channel. ஓகேவா? அந்த சேனல் கிரியேட் ஆயிருச்சு. சோ அந்த சேனலுக்கு என்ன பேர்? N சேனல். இப்ப என்ஹான்ஸ்மென்ட் மாஸ்ஃபெட்ல மாஸ்ஃபெட்னா எனக்கு டீடைலா புரிஞ்சிருச்சு. அதுல ஏன் N சேனல்ன்றது புரிஞ்சிருச்சு. Because by giving the gate source voltage we are forming the channel. That channel going to give the conduction path for my source. இது ரொம்ப சிம்பிளா சொல்லலாம். You have one land portion, another land portion. இடையில ஒரு C surface இருக்கு. எப்படி சார் இந்த லேண்ட் ஏல இருந்து பிக்கு வருவோம்? நம்ம ஒரு சேனல் கிரியேட் பண்ணுவோம், அதுக்கு பேர் வேற. வாட் இஸ் தட்? இது வந்து சி. இதுக்குள்ள எட்டி குதிச்சு நீச்சல் அடிச்சு இப்படி வரலாம். கரெக்ட் தானே? வேற என்ன பண்ணுவோம் நம்ம? வாட் we will create? We will bridge these two. கரெக்டா? அதுக்கு பேர் என்ன? இதுக்கு பேர் என்னது? பிரிட்ஜ். ஓகேவா? அதே பிரிட்ஜ் ஃபார்மேஷனுக்கு தான் இங்க என்ன சொல்றாங்க? சேனல். Okay, it is a induced N channel. Is it clear up to this?
Yes, sir.
Yes. Okay. Now. அப்புறம் இதுல இன்னொன்னு இருக்கு பாருங்க. இன்வர்ஷன் லேயர்னு இதுக்கு எதுக்கு பேர் வைக்கிறாங்க சார்? இன்வர்ஷன் லேயர். Why it is called as a inversion layer?
P இருக்க வேண்டிய இடத்துல நம்ம என்ன இன்வெர்ஸ்?
Very good. இன்வர்ட் இதெல்லாம் நீ லாஜிக் கேட்ல படிப்ப, நாட் கேட்னு ஒன்று வரும். சரியா? அதே மாதிரிதான் இங்க பி டைப் இருக்கு, இங்க நம்ம என்ன கிரியேட் பண்றோம். ஸோ எப்படி கிரியேட் பண்றோம்? இன்டியூஸ் பண்ணி கிரியேட் பண்றோம். Who is going to induce? VGS. Since it is a voltage source, இந்த டிவைஸ் என்ன கண்ட்ரோல் டிவைஸ் சார்? அவ்வளவுதான் பாரு, எல்லாமே 1-to-1 ரிலேஷன் இருக்கு. சரி, தென் இந்த சேனல் வந்து எப்ப பர்ஃபெக்ட்டா கிரியேட் ஆகும் அப்படின்னா, whenever see இப்ப பார்த்தனா if I say something to you, you won't respond immediately. நீ பெருசா ரெஸ்பாண்ட் பண்ண மாட்ட. ஒன்னு அப்படியே கொஞ்சம் கொஞ்சமா அந்த சேம் இதை இப்ப repeatedly says, if it crosses some level, you will give 3 responses. ஒன்னு சிரிக்கலாம், ஒன்னு அழுகலாம், ஒன்னு கோவப்படலாம். அந்த லெவலுக்கு பேர் என்ன சொல்றாங்க? threshold level. இது நமக்கு எவ்ரி ஹியூமனுக்கு அது இருக்கு. am I correct? நம்ம ரெஸ்பாண்ட் பண்ணுவோம் after reaching the threshold. In the same way, in the VGS la you have some threshold level. If you reaches the threshold or greater than that, then only this N channel will be perfectly formed. That N channel only going to aid the conduction. Okay, so on the threshold value varaikkum I need to adjust this VGS. The threshold தான் டிரான்சிஸ்டர்ல நம்ம ஒரு இன்னொரு வேல்யூ சொல்லியிருப்போம். Can you tell me what is that? Forward bias நீங்க ஒரு வோல்டேஜ் சொல்லுவோம். What is that value? cut in or knee. It is not a cut off. cut in or knee voltage. இங்க வேற பேர் வச்சிட்டாங்க. What is that? Threshold voltage. Please note down these new terms. It's very, very important. Threshold is known to you. You need to correlate with here. Threshold voltage கொடுக்கும்போது you will forget the perfect channel. So this channel now hereafter going to act as a one conductor. அவர் என்னவா ஆக்ட் ஆக போறாரு? ஒரு கண்டக்டர் ஆக்ட் ஆக போறாரு. ஓகேவா? Yes. Threshold you have 2 different notations in your textbook. VT ன்னு இருக்கலாம், or VTH ன்னு இருக்கலாம். ஓகேவா? In our slides also we will follow these 2 notations in the different places, so don't get confused. Okay, shall I move from here? Sir? Shall we move from here? Yes. Now channel form பண்ணியாச்சு. Channel form பண்ணதுக்கு அப்புறம் if I give the supply to PDS ல some voltage இருக்கனால, now there is current flow. பாசிட்டிவ்ல இருந்து நெகட்டிவ் வந்துருச்சா? உனக்கு எனக்கு க்ளோஸ் ஆன மாதிரி ஃபீல் இல்லைன்னா இந்த நெகட்டிவ் கொண்டு வந்து இங்க கனெக்ட் பண்ணிப்பாரு. இப்போ இந்த சர்க்யூட் க்ளோஸ் ஆயிடுச்சா சார்? இஸ் இட் மை சர்க்யூட் கெட் க்ளோஸ்ட்? க்ளோஸ் ஆயிடுச்சா சார்? Now there is a current flow in this channel that is called ID. What is the current? ID means what? Hello? Drain current. ID means drain current. Okay, note paniko. Direction is very, very important. Drain to source or source to drain?
Drain to source.
Okay, is it possible to reverse this direction? How you will reverse this?
P channel.
Okay, channel மாறும்போது வரதுக்கு சான்சஸ் இருக்கு. RL நம்ம இந்த polarity மாத்தினா என்ன ஆகும் சார்? If I put automatically direction change ஆயிடும். Don't get confused with that. Stick with this polarity and we will have the discussion. Okay, yes. Now successfully we created ID. Let me draw one small analogy to you people. This is drain terminal, this is source terminal, this is gate. Okay, this is what? Drain to source voltage. This is gate to source. Okay, if it is 0, it is an open switch. If it is greater than 0, how I need to modify? It is a closed switch. Is it clear, sir? Evlo simple on discussion. Yes, sir? If without any resistance, if I make the circuit, resistance will become 0. It will draw enormous current from the circuit. அப்ப MOSFET experiment பண்ணும்போது what I need to include in this circuit, one additional component varano to control the current flow. What I need to connect? One resistor. Sir. So that's all about the operation initial stages. Initial stage is the open or close. Inga VGC have some value. So VGC some value it is going to act as a closed switch. That's all. Now we will discuss little more points. The channel conductivity is said to be enhanced. Enhanced. Increase. Increase. If I increase the VGC, channel enhance, increase. Correct? Initially, light amount start. When it reaches threshold value, you will get the increased value. So the enhance this MOSFET is also called as an enhancement. Last class you know what is MOSFET. Then few slides before you know why it is N channel. Now you know why it is enhancement. These are all popular questions. You supposed to answer. Please note down. Shall we move from here? Shall we move from here? Yes. If you note down, please say yes. We will move to the next slide. Hello?
Yes, sir.
Yes. Now we will move. Next one, the immediate or equation. Don't get confused. Okay. I equal to what, sir? I equal to V by
R.
R. This could multiply panna 1 by R. How I can replace? G. Correct? Is it clear, sir? Is it clear? Okay. So ID current, we skipped the derivations. We are giving only the end result. We are giving the only end result. The drain current, okay, during VGC is greater than VT, the drain current related using this formula is very simple. Gate source, gate ko source ku enna voltage apply pannirukamo, that voltage minus the threshold voltage and square. It is going to give only voltage value. Am I correct, sir? Am I correct, sir? Am I correct? If I divide with resistor or multiply with conductor, I will get the current. Am I correct? So they found K is the function. This is the construction of a device. The constant. இந்த கான்ஸ்டன்ட் வந்து என்னோட டிவைஸோட கன்ஸ்ட்ரக்ஷனோட ஃபங்க்ஷன்றாங்க. அப்படின்னா ரொம்ப சிம்பிள். இது என்னவா இருக்கலாம் ரொம்ப யோசிக்க வேண்டியது இல்லை. நமக்கு ஒரு சேனல் ஃபார்ம் ஆகுது இல்ல, அந்த சேனலோட கண்டக்டிவிட்டின்னு வச்சுக்கலாமா? Shall we keep it as the conductivity of the channel in simple? இது எதை டிபெண்ட் பண்ணி இருக்குது? எதை டிபெண்ட் பண்ணி இருக்கு? டிவைஸோட ஃபேப்ரிகேஷனை டிபெண்ட் பண்ணி இருக்கு. Is it clear? Shall we have it like this? Shall we have it like this?
Yes, sir.
Yes. இது எந்த ஏரியான்னு புரியுதா? It related to the channel. சேனலோட டிபெண்டன்சின்றதை மட்டும் மைண்ட்ல இப்போதைக்கு வச்சுக்கோ. ஓகேவா? Then from that equation they are going to find what is the K. It's not a magic. Take these things to right side. You have to divide. Okay. So this formula will be helpful to us to analyze the characteristics a little further in the succeeding slides, not immediately. Okay. So please note down this formula. Please note down this formula. Then if you find a time, go to Google Okay, go to Google and do shopping. ஷாப்பிங் வந்து அவாய்ட் பண்ணிட்டாங்க கரெக்டா. பட் நம்ம வந்து கம்ப்யூட்டர் இன்ஜினியர்ஸ், நம்ம விர்ச்சுவலா ஷாப்பிங் பண்ணலாம். Go to Google shopping. Go to Google shopping and type EMOSFET. Understand, sir? Have you got the MOSFET? Hello, sir?
Yes, sir.
MOSFET வந்துருச்சா? என்ன சார் நீங்க 3 terminal நீங்க here we have more than 3 terminals. அப்ப இதெல்லாம் நம்ம என்னன்னு கண்டுபிடிச்சு படிக்கணும். ஓகேவா? So இதுதான் 3 terminal. It is looks like a 7805 or the regulator ICs. நம்ம ஆல்ரெடி பார்த்தோம்ல, அது மாதிரி இருக்கும். ஓகேவா? இது வந்து ஹீட் சிங்க்னுவாங்க. நம்ம வந்து இன்னொரு டெர்மினல் ஒரு ஆக்சுவலா 1 2 3 இருக்கு. கரெக்ட்டா சார்? Can you catch 1 2 3? What may be these three? What may be these 3 terminals? What may be these 3? Hello, sir. This is MOSFET. The 3 terminal என்னவா இருக்கும்?
Source, drain, gate.
Source, drain, gate. What may be the 4th one? This one? நம்ம டயகிராம்ல இருக்காது. இங்க இருக்கா பல்க் ஆர் பேஸ். இங்க இருந்து ஒரு சப்ஸ்ட்ரேட்ல இருந்து ஒரு டெர்மினல் எடுக்கிறோம்ல, that is this terminal we are not going to consider, but we are using this one. Okay, even though in the terminal வந்து effective-ஆன ஃபங்க்ஷனுக்கு ஒர்க் ஆகாதனால it is not said to be a 4 terminal device. It is always said as a 3 terminal. Okay, but in the 4th terminal we are using for some other purpose. Don't get confused now. But this terminal is already represented in our diagram. Okay, so effective ஆக கண்டக்ஷனுக்கு அது யூஸ் ஆகாதனால we are not taking into account this. Okay, sir? There are some components இது இன்டர்னலாவே கனெக்ட் பண்ணி வச்சிருப்பாங்க. Okay, is it clear up to this? அப்ப why here this many terminals? யாரா சொல்லலாமா? இவ்வளவு டெர்மினல் இருக்குன்னா இதுக்குள்ள எத்தனை MOSFET இருக்கும்? 1 or more than 1? These are all MOSFET pack, more than 1. அதெல்லாம் கொஞ்சம் டவுன்லோட் பண்ணி படிக்கணும். ஓகேவா? ஸோ இதுக்கு டேட்டா ஷீட் இங்க பார். This is called SMD component, surface mounting devices. 1 terminal, 2 terminal, 3 terminal. I will show you one video related to SMD package in the later classes. So this is through hole device. This is SMD. In your mobile phone, you are having only this kind of MOSFETs. Okay, wow? Yes. Now I will come back here. Why I said this? From here, you need to find the data sheet and download one data sheet. How to download data sheet? It will not available in the shopping. EMOSFET data sheet in type panne, download panne. It will be in the PDF format. Go through it. Okay. Go through பண்ணேனா உனக்கு அந்த Kன்ற கான்ஸ்டன்ட் எங்க இருக்குன்னு யாரா ஒருத்தவங்க கண்டுபிடிச்சிட்டு வந்து next classல சொல்லலாம். ஓகேவா? Yes, now I skipping that task. You do it yourself and find where the K is present in your data sheet. Okay, is it clear, sir, up to this? Yes. Now next one, applying increased drain voltage. So increased drain voltage apply பண்ணும்போது என்ன நடக்க போகுது? Which one? Increase in drain voltage means which one? This one, VDS. If I increase the drain voltage, ultimately I'm going to increase this and keeping VGS to be constant. எதை increase பண்றோம்? இதை increase பண்ற and keeping the gate source voltage as the constant. வச்சிட்டோம்னா okay, constant at value greater than threshold இருக்கணும். This should be greater than threshold voltage and kept constant, and I am going to increase this VDS. Increase பண்ணும்போது என்ன நடக்குதுன்னா it makes us the voltage drop across the channel. Okay, it is going to increase the VDS voltage drop. VDS drop na enna? Drain to source. இங்க இருக்கிற drop அது increase பண்ண போகுது. Okay, ma'am? Is it clear, sir? Is it clear? Is it clear?
Yes, sir.
இதை கான்ஸ்டன்டா வைக்கிற, இதை இன்க்ரீஸ் பண்ற. இதை கான்ஸ்டன்டா வச்சுட்டு இதை இன்க்ரீஸ் பண்ணனா ஒன்றும் நடக்காது. இங்க இருக்க டிராப் இன்க்ரீஸ் ஆகும். ஸோ அப்படி இன்க்ரீஸ் ஆச்சுன்னா ஓகே, அந்த பர்டிகுலர் வோல்டேஜுக்கு வேல்யூக்கு பேரு ஓகே, த அமௌண்ட் ஆஃப் விஜிஎஸ் இன்க்ரீஸ்ட், it should be VDS. Saji sir? Yes, this is VDS. That is called over drain voltage. Please make this one over drain voltage. VOV. Zero V எழுதிராத. This is not a zero. This is O. Okay va? So over drain voltage na இந்த VDS value beyond ஒரு particular value மேல increase பண்ணும்போது it is called as a over drain voltage. How to find the over drain voltage? VGS minus threshold. Okay va? VGS minus threshold will give you the over drain voltage. இது எங்க drop நடக்குது? In this channel. Okay va? Is it clear?
Yes, sir.
Okay, from the same equation, let me clarify this one in tomorrow's class. Okay, take down this equation alone. So how you will find VGS? Yes sir.
Gajan sir, sir edu கூப்பிட்டு?
Yes sir, yes sir. Sir, I will call you, no issue.
இல்ல நீங்க
ஆமா கூப்பிட்டுச்சு, I will call you, no issue. Okay, from this equation, how to arrive VGS? Take this minus this side, you will get VGS is equal to VTS plus V over voltage. Okay, so up to this it is clear, but here little confusion. I will clarify you in tomorrow's class. So when VDS is increased and VGS is kept constant, okay, that alone you keep it in your mind. VDS I am going to increase, and keeping this one constant will make you some drop. Okay, if beyond the threshold voltage, if you are applying, that is called over drain voltage. In detail we will see in the tomorrow's class, and take down these equations alone. Okay, is it clear up to this? Sorry for the confusion. I hope this is clear. This alone I need to clarify. Okay, yes, but the equations are perfect. Note down. Is it clear, sir? Hello?
Yes, sir.
Now we will move to the next slide. The same equation, we are going to apply these relations. And some other substitutions. I will explain you how you arrive this. VGD is equal to VGS minus VDS. இது எப்படி சார் எழுதுனாங்க? Now I will help you to write these equations. Very simple equation. Please listen. This is a KVL equation. Is it clear, sir? It is a KVL equation. I am start tracking the path. KVL nala it is the one closed path நமக்கு வேணும். Consider first source as a VGS. VGS எங்க போய் கனெக்ட் ஆயிருக்கு? VGS எப்படி கனெக்ட் ஆயிருக்குது? GD இந்த ரீஜன் மூலமா கனெக்ட் ஆகுது. ஓகேவா? So VGS is connected. Let me take it as a one small resistance. இந்த பாத்துல some resistance இருக்கும்ல, அந்த ஒரு பாத்து நான் எடுத்துக்கிறேன். That is what RGD ன்னு வச்சுக்கலாம். ஓகேவா? Then அதுல இருந்து எங்க போகுது? Positive terminal of VDS. So positive terminal of VDS. Then it connected with the ground. இப்படி ஒரு loop எடுத்துக்கிறாங்க. They are going to take this loop to write the KVL equation. Okay. So if I write the KVL equation for this loop, so how you will write the equation? Very simple. See, here I am having one drop, here I am having one source, but here I need to observe one thing. the current direction is in this direction. So VDS ல இருந்து எனக்கு இப்படி வரணும், இப்படி current direction வந்து நான் எழுதணும். ஓகேவா? Shall I start write the equation from VDS? VDS ல இருந்து எழுத ஆரம்பிக்கலாமா? எப்படி எழுதலாம்? VDS, okay, VDS, there is a drop across this element. What is the drop? இதுக்கு என்ன பேர் வச்சிருக்காங்க? What is the name of the drop? What is the name of the drop? VGD. VGD. So இங்க பாரு, இங்க இருந்து இப்படி வருது VGD drop, கரெக்டா? Then இங்க இருக்க source. இது மூணை ரிலேட் பண்ணி I need to write the equation. So let we will go with this diagram. It will very easy. இங்க பாரு, இங்க இருந்து வந்து இந்த drop, then this source. இதுக்கு ஒரு KVL equation எழுதலாமா? எப்படி எழுதலாம்? எங்க இருந்து ஸ்டார்ட் பண்ணி எழுதுறீங்க? Since I am having VGD reference வச்சிருக்கனால நான் drop இப்படி தான் நோட்டேட் பண்ணனும். So let me go with this VGS. இந்த drop பாத்தீங்கன்னா current direction is reverse. Current direction இப்படி வருது VGD ல. So I need to consider this as opposite. So அப்ப VGS minus VGD, then plus ல வந்து enter ஆகுது. அப்ப என்னது? Minus VDS equal to 0. இதுல VGD VDS அந்த பக்கம் போனா என்ன ஆயிரும்? Take VGD right side. அப்ப என்ன வரும்? VGS minus VDS equal to VGD. Are you getting this equation? It is a simple KVL. Two different sources in the current directions may get you to confuse. Okay va? So அப்ப நம்ம எந்த path எடுத்தா ஈஸியா இருக்கும்? Take this path. இந்த path எடுத்து எழுதணும். இந்த path எடுத்து எழுதும்போது so இது வந்து potential rise. இங்க வந்து this is the drop, this is also drop. So அதனால தான் என்ன பண்ணிருக்காங்க? VGS minus VDS எடுத்திருக்கு. ஓகேவா? So in the equation now we are going to substitute what is VGS we found in the previous equation, VT plus VO. If you substitute this, you will get this equation. Is it clear? Simple KVL and one small substitution will give you the equation of VGD. Okay. So is it clear? Is it clear, or still you having any confusion in this equation? You no need to get confused. Take down the equation. Okay. Hello. எந்த லூப்புக்கு எழுதியிருக்குன்றத மட்டும் அண்டர்ஸ்டாண்ட் பண்ணிக்கோ. VGC இது, then இது, இந்த லூப்புக்கு எழுதியிருக்கும் KVL. Is it clear, sir? Hello.
Yes, sir.
Confuse ஆகுது, எனக்கு இது clear understand ஆகணும்னா வெயிட் பண்ணு. Let me draw it once again and explain to you. Okay. Then now we are going to see one more thing here. Whenever we are giving this input voltage to the system, input voltage is a system, and if you increase this voltage, beyond the threshold voltage, your channel will get disturbed, and also the formation will come like this, or tapered shape create agum. When this will happen? If you increase this VDS beyond threshold value. Okay, if you increase this value beyond the threshold value, your channel will get the tapped shape. Okay, so this tapped shape will further increase if you increase the threshold voltage like this. So இப்போ உனக்கு channel disturb ஆயிருக்கா? Channel எப்படி disturb ஆயிருக்கு? Drain la it is very narrow, source la it is very big. Is it clear, sir? Is it clear? But before threshold and channel இப்படி இருந்தது, கரெக்டா? No disruption. But if you increase your drain source voltage further, you will get like this. Okay, please note down this two diagrams. Note down these two diagrams. So the depth of the channel under the first category is the function of this V over voltage minus VDS. In this end, once it reaches the source, it is a function of this constant into the over voltage. Okay, so in the voltage now we have discussed in this slide, am I correct? Over drain voltage. Okay, ஏன் இது டிஸ்கஸ் பண்ணணும் இப்ப புரியுதா? Over drain voltage எதுக்கு டிஸ்கஸ் பண்ணோம்? This over drain voltage will disturb your channel. இந்த சேனல் எப்படி இருக்கும்? Drain கிட்ட கொஞ்சம் கம்மியா இருக்கும், source கிட்ட அதிகமா இருக்கும். If you further you increase and if reaches to over voltage, whenever my VDS voltage value reaches to over voltage, this function will become 0. Am I correct, sir? Mathematically this will become 0, therefore I am getting sharp edge. Mathematically understand ஆகுதா? இந்த ரெண்டு term equal ஆயிட்டு என்ன ஆயிரும்? This width will become 0. Only the over voltage will present here. So like that your channel will get disturbed. But the beauty of one more thing is it won't affect the current through the channel. It won't affect the current through the channel. Please make note of this. This hello. Okay, in the effect enna peru? What is the name of this effect? What is the name of this effect? Please refer the channel and shell. Drain la 0 um source itla or limited um irunduchina and idukku per enna sir? Pinch off. Channel pinch off. Is it clear up to this? Yes.
Yes, sir.
Channel வந்து எப்ப இது மாதிரி சேஞ்ச் ஆகும்? When your channel will get disturbed, if keep on increase your drain source voltage. Drain source voltage increase பண்ண your channel will get disturbed. If it reaches exactly your over voltage, you will get this. Okay, sir? What is pinch off? What is pinch off effect? That the depth of the channel at drain becomes 0. The mari. But 2 mark la ketalum you can draw this diagram and you can explain. Okay?
Yes, sir.
Shall we move to one more slide? Shall we move to the one more slide?
Yes, sir.
This is the last slide. What is this? Can anyone tell me what is this? What is this? P-channel enhancement MOSFET. So P-channel enhancement MOSFET. What are all the difference between your N-channel and P-channel MOSFET? What is the difference between your N-channel and P-channel? So left hand side ஒன்னு இருக்கணும், right hand side ஒன்னு இருக்கணும். Correct? Then only we can compare. நம்ம brain அப்பதான் easier compare பண்ணும். Okay. என்னென்ன changes இருக்குன்னு சொன்னா we will go for the lunch. Okay?
Substrate and channel.
Substrate, very good. Substrate, this is P, here it is L. Okay. What are the other difference? What are the other differences? Channel induced P channel, inga induced N channel. Okay, induced N channel. Okay, then what are the other things? What are the other changes? Quick.
Change.
Which one?
The polarity of VGS.
Very good. Polarity of VGS and VDS. எல்லாத்தையும் நோட் பண்ணீங்க, மேஜரா இன்னும் நோட் பண்ணாமே இருக்கீங்க. What is that? Can anyone tell? What about the source and drain? It is N plus or P plus?
P plus.
This is P plus. The doping is the P. Here doping is N. Okay. Remaining things are very much similar to the N-channel MOSFET. So we are not going to discuss much operations over here. Any idea? Sir? If I give VGS to the system, electron move ஆச்சு. இங்க என்ன move ஆகி இது create ஆயிருக்கும்? அவ்வளவுதான் சார். Holes will start move from N-type material to here. Then it will form the P channel. Then remaining stories are same. Okay. I want to ask you one question and wind up the session. In our transistor biasing, we studied one thing. Whenever I am biasing my base to emitter region with the source, I will find one current in this part that is called IB. If my base current is 0, my transistor will act as an open switch. If base current is greater than 0, it will be act as a closed switch. Please observe here. Here I have given some VGS value. கொடுத்து எனக்கு channel form ஆயிருச்சு, conduction இருக்கு. But my IG is 0, sir. Is it correct or wrong? It is correct or wrong? என்னோட MOSFET conductionல இருக்கும்போது gate current 0வா இருக்குமா இல்ல greater than 0வா இருக்குமா? Theoretically 0. Don't get confused. Okay, it is a voltage control device. இங்க நம்ம voltage தான் நம்ம discuss பண்ணணும். This will form only the channel, not the current. With this we will conclude the today's class. So இந்த இத பொறுத்தளவுக்கு ID current measure பண்ணுவோம். IG current we never measure. Okay, measure பண்ணாலும் it will be very very negligible one. Okay, with this we will wind up the today's class. And I want to convey one thing to you people. Many of them waiting for your observation to get correct. Yesterday again I corrected our 1B experiment. Why I delayed 1B correction? Can anyone tell me? Why I delayed 1B correction? Can anyone tell me? Yeah, 1B correction ரொம்ப நாள் தள்ளி போட்டோம். Many duplications. Am I correct? Yes. Even yesterday night I found that more than 10 students still they are keeping the fake document and they are thinking that சார் வந்து பார்க்காம எப்படி திருத்திடுவாரு தப்பிச்சுக்கலாம் அப்படின்னு நினைச்சு. Okay, let me spell their roll number. 248, 224, 251, 217, 214, 118, 141, 241, 254, 255, 155, 211, 220, 229 is the only one student. நம்ம தப்பு பண்ணிருக்கோன்றத ஃபீல் பண்ணி அவர் மட்டும் கிளாஸ்ல எங்க சார் அப்லோட் பண்றது? எஸ், யுவர் ஃபார்ம் won't accept the response. ஃபார்முக்கு வெளியே CAA யூனிட் டெஸ்ட் கிளாஸ்க்கு அப்லோட் பண்ற மாதிரி கரெக்ட் பண்ணதை அப்லோட் பண்ணுங்கன்னு சொல்லி ஐ கேவ் அ லாங் டியூரேஷன். யாருமே இந்த பர்டிகுலர் ஸ்டூடெண்ட்ஸ் கரெக்ட் பண்ணவே இல்லை. எஸ்பெஷலி there are few students 252. Okay, then 115 ஆனா கால் பண்ணி சார் நான் 2 எக்ஸ்பெரிமெண்ட்டும் ஃபால்ஸா தான் சப்ஸ்டிட்யூட் பண்ணியிருக்கேன், நான் கரெக்ட் பண்றேன் அப்படின்னு சொல்லியிருக்காரு. Who is this 252? ஆனா 252 கிளாஸ்ல இருக்கீங்களா? Who is there? 252 இருக்குமா? Not there. கரெக்டா? அண்ணா சார் இன்னைக்கு பிரசன்டா சார் 252? சஜித் சார், and I will tell you one thing. Again I am going to give one more excuse. Next experiment இன்னைக்கு ஈவினிங் திருத்த ஆரம்பிப்பேன். ஃபேக் இருந்துச்சு அப்படின்னா, sorry to say this, you need to produce the apology letter, then only I will evaluate your lab mark. Okay va? Evening varaikkum let me give a time to you people to upload. Where to upload sir? Go to the, but in the recording only I am saying this, go and refer. Whoever left the class, please intimate them to observe the final minutes where they can submit the new submission. Go to your observation content. Okay, go to the observation assignment and open the assignment and upload the document without touching your form. Okay, your form won't receive the multiple submissions. Okay, go to this assignment. Say example, this is the 1B experiment. Click this 1B experiment. Let me show one person already submitted. How he has submitted, let me show. He only நிரஞ்சனா resubmit பண்ணிருக்காங்க. ஓகே, நிரஞ்சனா resubmission இங்க வெளிய பண்ணிருக்காங்க தெரியுதா? This is the ஃபார்முக்கு வெளிய சப்மிட் பண்ணிருக்காங்க. So like that you submit. We will consider this time as a excuse, and I think to give some mark rather than 0. Okay, but next experiments onwards, if I find anything false, I will block you from the lab experiments. Simply I will give you now itself a lab mark as a 0 to your tutor. Okay, don't irritate your faculty who is sitting and evaluating your things. Okay, அதே மாதிரி யூனிட் டெஸ்ட்ல யாராவது நான் ஃபேக்கா பண்ணிருக்கேன் அப்படின்னா ப்ளீஸ் அப்ரோச் மீ வெரி பிஃபோர். ஓகேவா, முன்னாடியே சொல்லி நான் திருத்துறதுக்கு முன்னாடி நான் திருத்திட்டு அப்புறம் நான்